Hello everyone, I am watching Duong from Team Hay. Uh, this is our implementation. Uh, we consider that the D2D connection in 5G is basically denote the device to device as a node to a node connection in 5G networks. So here we use uh, 5G symbol simulation to calculate the final maximum throughput. So as you can see here we have some of the variables like bandwidth of your 5G channel, the subcarriers, uh, which is the subcarrier spacing in this table. Yeah. So with the horizontal is your time domain, and the frequency domains is your vertical line. So in the normal situation, the subcarrier spacing will be 30, and I will also use that to calculate the example. So back to the code, we have the MIMO layers from 1 to 4, and the choice to choose from a CKI index or MCS index. This index is correspond to it will change this variable y, sorry, and it will change the TP size, and the TP size will affect the throughput. So it will also have the DL slots, which is the download uplink slots, and the number of PRP, which is available number for we minus the 4 bit, which is the 4 that will be used for the gate. We don't use it, and here you can see the specific efficiency of MCS and CKI. I just wrote down from the table like this. Yes, this is the table for the CKI index. We have from 0 to 15, and the efficiency is the same corresponding. Also for the MCS, you will see that is 28 to 31. It is the reversed, and we just from 0 to 27, that will be work in the normal solution. And the final final fraction we have is the block error target. So the block error rate is just like how your throughput, how your channel bandwidth can go through without any objective, without any thing that block on the way. So we have it at a percentage like from 0 to 100, and our math to calculate it just like the multiplication of TB size and the number PRBs, which has been minus by 4, and the DL slots, which is normally 160 1600. And the more layers, it could be 1 to 4, and the blur target which will be changed by the percentage, and we division down to 10 to the 6 power of 6. And now I will go to some example for you to understand more about this. Okay, so here we have run implementation, and first you have to input your 5G channel bandwidth in megahertz. So normally I will just put 100. For the subcarrier spacing in kilohertz, I will put 30, and finally the number of MIMO layers I will put 4 as maximum MIMO layers. And now we will have to choose if we use the CKI or the MCS index to it will be affect the final solution. So I will first demonstrate the MCS way. So if you choose MCS, you put 1, and the corresponding CKI index, the MCS index, I will choose 27, just maximum. And the block error rate or error rate, here I will put 0, as there is no block error rate in this situation. So here we have the answer. Our available number of POP will be 273, and the maximum throughput for this configuration is 707. Yes, some like kind of that. Now I will do the CKI way, and we will compare the result. So here I will also have the bandwidth to 100. The subcarrier spacing will be 30. MIMO layers will be 4. And for the CKI or MCS chosen, I will choose CKI, and I will just put the maximum of the CKI index, which is 50, and the block error rate will also be 0. Now, as you can see, the available number of POP is also 273. The maximum throughput for this configuration is also 1707. Yeah. So changing the index from the table, like these two tables, you can see that for the CKI index, the 15 will correspond to the spatial efficiency of 7.4063, and also for the MCS index 27 will also be 7.463. So there's no changing in this number values in the formula. So now if I imply the block error rate in the formula, so here we have 130 for MIMO layers. Just put the MCS and 27, and the percentage of the block error rate I will put to 20. Yeah, now you can see that the available number of POPs is still 273, but the maximum throughput for this configuration is decreased from 1707 to 136.5.1152. So it decreased the maximum throughput, which means the throughput of your Wi-Fi or here the 5G is much slower, 20%. So this is the image of what I just did. So normally, example like you have 10 seconds to put like 100 megabit. So now there will be 20% of block error rate, which means the two of the megabit slot has been like lost on the way. So now the throughput estimated just 8 megabits per second, not 10 like normal. And that's it for my presentation about the implementation. And I will put the in the description the link of the YouTube that I learned from, like he did here. You can see he has the clearer version of what I did. And thank you.